Hi everyone, and welcome to this training video. In this video, I show you how real-time intelligence in Microsoft Fabric provides end-to-end solutions for event-driven scenarios and streaming data. First, we will ingest JSON files coming from Microsoft Azure Event Hubs, stream them through Microsoft Fabric EventStream, and store them in Microsoft Fabric EventHouse KQL Database. Then we will use KQL queries to transform and analyze the data. By then, you will see how simple it is to go from raw event streams to structured and insightful data ready for analysis and visualization. Okay, great. Let me go to real-time intelligent Microsoft Fabric architecture. This diagram shows the real-time intelligent architecture in Microsoft Fabric. It demonstrates how data from multiple sources like Kafka, SQL Server, or other sources is ingested through the event stream, analyzed and transformed using KQL query sets, and then visualization with tools like Power BI and real-time dashboard. When you create the event house, the name the same KQL database with the same name as the event house name will be created automatically, and inside the KQL database you have KQL query set. You can run your KQL queries to analyze and transform the data and prepare it for real-time dashboard and Power BI. So in order to demonstrate that, let me go to Microsoft Fabric. This is the main page of the Microsoft Fabric. Before starting, if you are interested to get hands-on with Microsoft Fabric and want to take advantage of the 6-day free trial to use its services, that includes full access to all of the features. When you create the workspace, you can access all of the features. If you are interested, you can leave comments, then I will help you to create it. So before starting the project, the first and main step is creating the workspace. A workspace is a collaborative area where you and your team can store and manage and develop all Fabric items. Let me refresh the whole page of the Microsoft Fabric first. Go to workspace, new workspace, and name it, for example, I suggest you name workspace after the project name. When you are dealing with several projects, so it's better to better for relevancy to find your project. So you have to separate several workspace related to several projects. Every project is related to a specific workspace with the same name and relevant name of the project name. So because this project is related to KQL, I name it my demo project KQL. My demo project KQL is the name of the workspace related to our project. Let's hit apply. So this is the main page of the workspace. You can add every item you need in your project. The first item I need is event stream is here. You can hit EventStream and name it my demo project EventStream, my demo project KQL, my demo project KQL EventStream. Hit create. It takes less than 1 minute to create it. Yes, if you go back to your workspace, this is the workspace. This is the first item you was created. You can add source. There are several sources can you connect to Microsoft Fabric EventStream and ingest your data inside into Microsoft Fabric. In this project, I use Microsoft Azure Event Hub and load the JSON file into and bring all of the JSON file inside the Microsoft Fabric and store them in the KQL database. So in order to demonstrate, first I need to create this service in Microsoft Azure. So this is the main page of the Microsoft Azure. First, you need to create a resource group. Resource group is a container or folder. You can store all of the service and resources you need in your project. It's better for management. So I will create the resource group name RG with the nearest region to your location and hit create. So it was created. It takes a couple of seconds to, you can see the resource group here, and you can create your resource. Our resource is Microsoft Azure Event Hub. We name it Event Hub here, and this is the service Event Hubs. Create, curate, and this is the Event Hubs. Microsoft Azure Event Hub is a real-time data ingestion service that can receive millions of events per second. The event in this project is JSON file, so it acts as a data streaming platform. So the namespace name is the name of the service, Microsoft Azure Event Hub. I name it my demo project, my demo project KQL, my demo project KQL Event Hub. The region, you have to choose the nearest one, and here is the basic, the cheapest one. Advanced network tags, and then create. It takes roughly 1 minute to see this service. Let me go back to resource group. This is the resource group, and inside the resource group we have, it is still running. When you have Azure Event Hub, application and IoT devices can send event data like JSON file to Event Hub, and Event Hub keeps this data for consumers like Kafka. Now we can create one or more Event Hub inside this service. So I name it Event Hub 1. Partition count, it's a way to divide event data into a smaller section. When you divide into smaller sections, when events are sent to an Event Hub, they are distributed across partition. when you distribute it across partitions, it increases scalability and performance. The minimum is 1 and the maximum is 32. We leave it as default, and the retention time is 1 hour. After 1 hour, the event that was sent to Event Hub will be deleted with this cleanup policy. So capture and create. It created, and you can see in the entity Event Hub, yes, this Event Hub, we have one Event Hub inside this service. So we can connect Microsoft Fabric EventStream to this Event Hub. Let hit a new connection, and namespace is this, is Event Hub 1, and authentication card, share access key name. If you go here, this is the share access key name, and paste it here, and when you navigate inside, you can copy primary key and paste it here. So let it connect. Next, add, and you can see the canvas of the Microsoft Fabric event stream. So this is a source, this is the event stream, and now we need to have destination. So when the JSON file arrives to Microsoft Azure Event Hub, event stream captured and loaded into destination. Our destination is EventHouse KQL Database. Before adding here, we have to go to our workspace and add new item. The new item is event house here, and name it my demo project KQL event house. We can like this event house. That is create. If you go back to workspace, we can see here KQL database. When you create the event house, the KQL database will be created with the same name as the event house name. So let me go to workspace, and here workspace, here KQL, here KQL query set. This is the default query. You can delete it, and if you go to here to close it here, you can add your destination. The destination is event house, and you can see here we need the table. First we have to create the table, and you can choose the KQL, and here you can create here, or you can run KQL query to create the table. In order to demonstrate that, first let me go to KQL database and go here, and you can run KQL query to create the table and doing the transformation. First, we need the table to run the KQL query to create the table, and this table used as a destination for our source, and this table can be used for the source for other transformation for our medallion architecture. So let me go to KQL and copy our codes and paste that here. This is the syntax of KQL query. In medallion architecture, by running this query, you can create the raw data table in the bronze layer. Let me run it. And you can see the columns: price, int, bedroom, bathroom, and parking and furnishing status, with the same, as you can see here, with the same JSON file key value pair. This is the JSON file key value pair. So by running this, you can see in the bronze you have raw data. Now we are ready to go to here, hit edit, and here you can have KQL and table, and hit save. This is the process of ETL. First, JSON file arrives, and Microsoft Azure Event Hub move it to KQL Database raw data table as a destination, and this destination is the source of our transformation for medallion architecture for silver and gold layer. We first, in order to demonstrate our process, we need to go to Microsoft Azure Event Hub and load the JSON file, entity and event hub. This is the event hub. And to Data Explorer, you can send event here. For testing, I go to first, 2 records included inside the first file of JSON file. Let me send. If you hit refresh, it takes time. Yes, it takes less than 1 minute, and you can see 3 last columns: partition ID and event process UTC item is a metadata that EventStream added. And when you refresh the destination, you have to see these 2 records, these 2 JSON records of the first JSON file. It takes time. You have to wait. This, and a schema mismatch. Yes, the schema mismatch is something like this. We have 3 columns here. Let me data preview. Let me here. Let me go here and data preview. As you can see here, we have 3 last columns, but in the raw data table, we don't have 3. In order to solve this, I have to first delete this and add one transformation manage field. and this manage field, we can here first name it deleted columns and remove this 3 last columns that as a metadata EventStream added, and then save it, and then connect how to connect this. Let me hit publish. Yes, you can see here that it takes time. Okay, great. Both activated. So when you hit refresh, you can see no data because they are already loaded the JSON file. In order to demonstrate the whole of the process, we need to add new JSON file, and now here you have to have 4 records. And here you have to have 2 records. It takes time. You have to wait. Changing, yes. Yes, you can see 2 records. So if you go back to your workspace, as you can see here in the KQL database, here you can do your transformation in Medallion architecture, bronze, silver, and gold. Let me go step by step. So before doing everything, let me notice that the advanced topic in the KQL database and is update policy. If you go here in 3 dots, new, you can see table update policy, and you can see the default query you can customize in accordance with your project. The update policy you can see here is automation mechanism. This triggers when new data is written to the source table. When the new data is written here in the source table, this update policy automatically runs and doing the transformation with this query and loaded the transform data in the target table. So it's a very advanced feature you can use for transformation, and the advantage behind is multiple update policies can be defined on a single table, allowing for different transformations and saving data to multiple tables simultaneously. I already customized this update policy, and this update policy needs this query, this function for transformation, and the function is adding a new column capacity, and is the summation of bedroom and bathroom, and then cast into int. This is the function called transform raw data. Let me run it first, and in the function you can see transform data. And after transformation, we need the destination in the silver layer to ingest the transform data into the target table. And the name of the target table is transform data. Let me first run this query, and along with the other columns, we add just only the capacity column to can host the transform the data. So in the silver, you can see the transform data is available now. So let me go again in the KQL query set. So here, the properties inside the update policy is first is enable true, source is raw data, destination is transform data, and query is this function. And there are two properties here, is transactional and propagate ingestion properties. Is transactional indicates whether the transformation and the ingestion happen transactionally or not. If true, the ingestion into target table is done in the same transaction as the ingestion into the source table here. So it means both succeed or both fail. So the default is false. And it means they are independent. I mean, ingestion in the source table can succeed even if the transformation and loading to target table fails. We leave it as default false. There is another property named propagate ingestion properties. The default is false, and this property controls ingestion timestamp or source metadata, whether are passed from source to target or not. When it's true, the source metadata and the ingestion timestamp from source to target, when it's true, is passed, and when it's false, it doesn't pass, and we leave it as default because we don't want to pass this metadata from source, that is raw data, to target table name transform data. We don't want to pass this metadata. We leave it as default false. So let me run this update policy. As you know, we have two records in the raw data. Let me go to Microsoft Azure and load new JSON file. And here you have to see two records in the raw data, as you can see here. In the transform data, you have to see two records, and here in raw data you have to see 4 records. So we already ingested 2 records. Now in the Azure portal, when you loaded the new JSON file, the raw data is 2 and transform data, the raw data is 4 and transform data is 2, as you can see here, and the capacity column as a transform column added at the end. If I brief all of the process, I already load the JSON file here, and the Microsoft Azure Event Hub, when you load it in Microsoft Azure Event Hub, EventStream capture it and remove the last 3 columns and load it to raw data. As soon as you see the raw data, the new JSON file ingested to raw data, this update policy without manual intervention automatically trigger and run this query on top of the raw data table and load it to destination transform data. So and in the target table named transform data, you can see transform column and the updated record, I mean the last two records related to last JSON file we uploaded. So regarding the materials view, creating a materials view return an up-to-date result of the aggregation query, and it is faster than running the aggregation query directly over the source table. When you have the aggregation query, better to embed this aggregation query inside the materials view, and it returns the update result. So let me run first, and you can see here when you run it, the materials view in the gold layer as a last transformation. Our last transformation will be visible here, and this aggregation is grouped by furnisher status and take the maximum capacity. So if I run it, it's definitely empty. In order to demonstrate whole of the process, we need to ingest new JSON file. I call it 4. As soon as it's loaded to Microsoft Azure Event Hub, you have to see this record, as you can see here. And this is the query for visualization on top of this materials view in the gold layer in medallion architecture, and with the column chart with the Y column and X column like this. So let me run another JSON file here, the last JSON file. As soon as loaded, like this pipeline, this JSON file will be loaded into raw data. Let me refresh it. And this update policy automatically run and doing this transformation that that was written inside the function, run on top of that and load it to transform data. Let me run it again. You can see, let me open this. Bathroom is 33 and bedroom is 5. You can see these two last column, these two last records. And another one is 2 and 1. You can see here 2 and 1. So with the capacity as a transform column, you can see here. So now the materials view updated automatically, and you can see this furnished in the furnishing status column. As you can see here, it must be 38, and here 38. So let me show you real-time dashboard. Instead of running this query in the KQL query set, we can have real-time dashboard. Let me go back to workspace and add new item for real-time dashboard. I name real-time dashboard KQL project, it creates, and you can see this tile, and you can embed the KQL query inside this tile and make a visualization in real time. Instead of the manually running this query, I copy or cut here and paste it. First, change from view to edit, add data source is EventHouse KQL query, and we select and connect it, and yes, add it and paste here. So let me run it, and when you save it and go to workspace here, you can see the workspace here. Editing, and new data source, connect, 5 minutes. I forgot to mention here the time of the refreshing automatically every 10 minutes, 10 seconds, and I add the title and paste here and apply changes. Let me go back to edit, visualize, and here visualize I can change from table to, for example, pie chart. Here you can see apply changes, and here you can see the online real-time dashboard. This tile, the underlining of this tile is if you hit edit this query, and the Y column is max capacity and the X column is furnishing status. We have 82.6% furnish, semi-furnish, and unfurnished, and you can visualize here in this tile, and is real time. As soon as the data alter, this visualization will be changed. So let's save it first, and in order to demonstrate whole of the process, we need to add new JSON file. Let me open this and create the new file, name it 6JSON, and here, and copy, for example, let me see in the RT, for unfurnished is 6.5, and for 6.5 you can see for furnished, for unfurnished, let me copy this record and create a new JSON file. And for unfurnished, I mentioned this, instead of 2, I mentioned 50, just only for demonstration. Let's save it and go to Microsoft Azure Event Hub and send this new JSON file. Let's hit refresh, and you can see the percentage of this JSON file that I can see here is unfurnished, change from 6.5 to 54.3, and this is the real-time dashboard. Underline this type, you can see two parameters, capacity and the maximum capacity with the group by in the furnishing status column, and the maximum one will be demonstrated here. And when you change the unfurnished from 2 or 3 to 50, as you can see here, this pie chart change like this. So this process, this ETL pipeline, with the help of the KQL query set, as you can see here, doing all of the transformation in medallion architecture from bronze, silver, and the last one is a gold layer for materials view. And you can see this whole of the process will be done automatically without manual intervention. And this Microsoft Fabric EventStream ingests the JSON file as soon as the new JSON file arrives in the Microsoft Azure Event Hub, capture it, deleted the last 3 columns, loaded to raw data table, and KQL query set doing the transformation, and this visualization for this type visualize the real-time data. I hope you found this video helpful. If you enjoyed this session and want to keep learning more about Databricks, Microsoft Azure, Microsoft Fabric, Snowflake, Azure DevOps, Terraform, dbt, and so on, make sure to subscribe to the channel and turn on the notification bell. I'll be posting more hands-on tutorials and real-world data engineering projects. Thank you for watching. If you have any question, just leave a comment.